Hello and welcome back. That we have discussed about the response spectrum, earthquake inputs, dynamic analysis, and we will do the static analysis. So let me define the floor loads, wall loads. Floor load is a two types, live load and dead loads, and we have the wall loads on the frame like partition walls. We can consider partition wall as a uh, dead load on the floor, and we can put this will be in term of force per unit area, force intensity we can call, and other is running meter, force in running meter, like wall loads for the frame structure. So we have discussed about the about ETABS basic uses. So UBC 97. Okay, so here we put the some. Let me increase the scale here. These are our zones. Total we have 5 zones, 1, 2, 3, 4, 5, and this zone of Pakistan. So you have your own codes, but here primarily we will discuss the UBC 97. This NV source here should be the CA and CV coefficients. So for in our case, this will be the soil profile will be D, and zone factor will be, you know, that we will be 3. So this is our zone factor 0.36, like this our zone factor 0.54. So this is in ETABS. In previous session we have included like load patterns, seismic load modify. So here is as default, this is user definition and per code. So soil type D and zone 3, it automatically calculates this program, and this is 8.5. It depend on the occupancy, and it also depend on the zones, which zone you belong. So normally when you have special movement resisting frame, you should keep it 8.5 meter for RCC frame structure. So there are different, it also defined in UBC 97. Okay, so these are all the code limitations. Here you can see this is the table 16N, structural systems. Okay, so here is our R. So this is 8.5 for the movement resisting frame, special movement resisting frame in row 3 here. Okay, so let me define the loads. This already we have meshed our structure. So let me define the frame, the slab load first. So keep this is as a all story. This modeling purpose, we will make some, you know, that we will put the loads without carrying the roof load and without carrying the first floor and second floor, like the floor loads. So floor load depend on the occupancy, like a assembly structure have more live loads, like mosque have more live loads, schools have more live loads, and residential building have less live loads, commercial building have more live loads. It depend on the uh, building usage and occupancy. So now I select all these loads, and I select all these structure. So or I can select easily without selecting these columns and this one. I just go assign, select, let me select selection, here property, frame, slab property. So select this one, slab 1. Okay, now you selected slab 1. So let's go and now go assign. So here assign shell loads, uniform shell load. Okay, so this will be live load. Okay, so live load depend on the occupancy. I already told you though, so you can calculate it. So I keep for my tutorial purpose 2.5 kilonewton per meter. Make sure the units and make sure this load pattern name and replace if you want to add something, some fraction on this, okay, but I have no other load already, so I keep this option on and just apply. Okay, then I change this one into surface dead load. Just select here, and surface dead load depend on the your finishings like tiles, marbles, whatever finishing you have. Like we on the floors our finishing is different as compared to on the roofs. Accessible roof have lie load different, and like this. So it depend on the, if you know the tile density, you can calculate the per meter force in term of kilonewton or in term of pounds, whatever unit you have, and it will be in the direction of gravity. Okay, so I keep is 3.2. Let's suppose my calculation is marble calculation or tile calculation, sand calculation of the layers of the floor. Okay, let me apply. Okay, apply. Okay, no selection is found, so you go and just select previous selection and apply, and okay. Now you go and check, right click here, and your loads, so two loads already applied, so you already confirm. So next, okay, make it okay, and just go. This is all story, let all story be open, but I need to change this, let all story select, go selection. Okay, selection, and properties, frame section, beam 1, select. So your all beams are selected, but on some beams there is no uh, walls, so no need to apply the running meter load there. So you just deselect this one, so it's very congested. Let me off this congestion of the slab portion. Check here, and joint off, floors off, apply. Okay, now no need to select this one. Okay, this is a corridor, no need to select this one. If no need to select this one. Okay, now this is all story. Come up. Okay, now you are at the roof, so make it a one story, and deselect all this one. Only periphery beam will be selected. Now your periphery beam are selected. Other downside, the selection is same as it is, because I change here from all story to one story. When you are changing one story, then only changes will be done on the one story. So this is one story. Okay, so no need to select. Let me deselect on the roof. No need to select this one. I will tell you why I am deselecting this. Deselect. Okay, assign frame load, distributed load, and my unit weight or density of the unit weight of wall is, because this is block masonry, so 24 kilonewton, and height is 3 and width is zero point 0.2 meter. So from this I get 14.5, so 14.4 I put 14.5, and I just say apply. Now my load is applied. Let, okay, or you can go like this, and okay, just say okay. You select the periphery beams to apply the load of the parapet. Just go. No. Okay. Assign frame load. Oh, no, 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 no. Assign frame load. Change the wall load है कि make it 5 meter. Round about 5 meter. Apply. Okay. Here your load is 5 meter and just go down. Here load is 14 meter. Okay. Now you have done with your loads. So let's do the analysis. Run the analysis. Before run the analysis, you can check the analysis from here. Analyze. So you can check. Just I would check warning, ETABS, series warn. Let's okay. If you do the models carefully, then there will be no warning. Just this is displacement of dead load. Now change this one. Displacement, deform shape, combination by some combination. I choose combination term. Okay. So start your animation. Okay. This is your deformation. Okay. So you can also put your deformation here and make the section properties extrude frame. Okay. Apply. So start your animation here. So this is your animation. Now go and concrete frame design preferences. Now you can change your preferences, but I put 318 14. Okay, and just select concrete frame design, run and check. Okay, so here maybe you can check by the elevation to whether your some column are under stress or not. By using this move up list, here you see no member is under stress. Okay, some red lines are there but no member is under stress. So almost your column is your frame structure is passed. So you make the groups of these reinforcements. Some 3 or 4 beam types you can make. Not you can design every element on the base of the ETAB result. You need to make the groups of these results and decide the reinforcement on base of that groups. Okay, which is near give the near reinforcement after applying the number of bars and size of bar. So this is about uh, the design of the two-story building. So this is your reinforcement results. So in the upcoming video we will check the drift velocity, shear force, and these earthquake parameters. So you can stay connected with us for the next videos. Thank you.